Okay, hey, I'm Greg. I'm a Scala developer here at Hotels.com. And I'm here to talk to you about RobBot. So, what is RobBot? A while ago, our Scrum Master went on holiday for 2 weeks, and we realized that would mean someone else would have to run stand-up. And that's a lot of work. So, our intern, who's in the room somewhere, wrote a bash script that would kind of simulate the stuff that our Scrum Master does during stand-up. So this used the say command in OS X. Is people familiar with the say command? So just like you do say something in the terminal, and it will say it to you, right? So I saw this bash script, and I immediately thought, this should be a free monad. I want to use a free monad. So honestly, it's just like a little toy project, and I just wanted to play around with this technique because it's nothing new. Like Runar of Functional Programming Scala fame, the book Functional Programming Scala. He was talking about this stuff like 3 years ago, but I've only just got around to playing with it. So this is why I played with it. Played with it on. So what is a free monad? Well, let's start a little bit more basic. What is a monad? We're using free monads, but first we need to have a good understanding of what a monad is. So a monad is a data type which conforms to the monad laws. It implements point, and it implements an associative flat map operation. What does that mean? The laws don't really give you any intuition around what a monad is. They're accurate, but they don't really give you any intuition. So one intuition which we're going to use for today is a monad allows you to build pipelines that process some data. Each stage of the pipeline, the monad gives you some extra processing rules that you can use. And we use FlatMap to compose monads together. And if you're doing Scala day to day, then you're already using them, of course. So we have a bunch of monads that model like a successful value or like a error case or a bad case.
Right.
So,
sorry, could you just hold the mic up a bit further to your mouth? It's
absolutely.
A little bit quiet back here.
Okay, thank you.
Thank you.
So option is a case of this, right? So we have some in the good case and none in the bad case. And we have try, which is like success or failure, and stuff like this. And then we can imagine this is, this could be any of those monads. Like when we get the user, this could fail or be none, and then that will short circuit this program. So with these monads, like option and try, the intuition is that you can short circuit. Basically, that's the effect it gives you. Another one that everyone's using, obviously, is list. So with list, it's like a non-deterministic computation. So it's not about short-circuiting, which you can do if you have an empty list. It's about having unknown number of output. And this is a completely different effect. So it's kind of hard to build an intuition around monad because the intuition is basically just you can compose things that have the same effect, but the effects can be quite different. And there's other monads. So those are the ones that people kind of, all Scala developers are using these. But there's other ones maybe you're not using. Let's have a look at some of those. So reader monad. Who's heard of reader monad? Cool, fair few. I know Dave's going to be talking about this later. So with this, you're composing computations which have the ability to ask for a value. One of the interesting things here is that here I'm creating this reader, and we have deferred execution. So it's only later on when I call read and pass it the value that we actually execute any of this. So this is like, again, completely different like option. It's not short-circuiting, but it's also not even eagerly evaluated. It's kind of deferred evaluation. Okay. Writer, this is another monad. This is one you can use if you want to do logging in a purely functional way. And here, every step in your pipeline or your program can output a log line if it wants. Use cases for this over just logging would be maybe you have some complex process with lots of business rules, and you only want to log if it failed. So like, if we just put debug logging on in production, we'll get like way too many logs, and that would be bad. So maybe we want to generate the debug level logging and only output it if it failed, and then throw it away if it succeeded. State monad. So these are computations. And when we say computations, we just mean the monad holds a function. So it holds a function here. And we can see that that function takes S, this is a state, so it takes a state and it produces a value, an output value, along with a state. So this can be, so this is quite powerful. So this can read state. It can also update state. And this is kind of like strictly more powerful than reader or writer. So with reader, we could read a value. We can do that here. With writer, we could append to some output, and we can do that with state as well. The other interesting thing here is that we can take one monad or mini program, and we can compose it. So, so here we're using get and set, but we're actually using flat map. So 4 is sugar for flat map, and we're composing that to form this modify state monad. So this is a very powerful concept. Like monads let you compose things, and you can compose little programs out of smaller monads. Okay, so that's monads. How do I free it? By free, we mean unrestricted. We don't mean free as in cost. These things actually do have some performance overhead. And by unrestricted, we mean that you can create a monad for any arbitrary data type. So this is sometimes referred to as algebra in the literature. So here we have a DSL for a standup. So in the standup, we're modeling my Scrum Master, and he could say something. So he just says some text, and we're capturing the return type of this command in our DSL. And when we say something, there's no return. When we receive, there's no input, but we return a string. And when we ask, we're asking a question and expecting some response. So this is very simple, hopefully. Just Scala case classes. We're capturing the output type, but otherwise pretty straightforward. What free gives us is the ability to take commands in that ADT and lift them into the free monad. So by doing free.liftf, we've now lifted this normal case class value into free. And you can kind of read this as this is a program in our stand-up DSL that returns unit. This is a program with like one statement, not very useful. But one of the things with Monad is we get flat map. Flat map allows us to compose. We can use that in full comprehension. So by lifting say into the monad, we can now compose it. So here we're saying something, and then we're asking for something, and we get back a response, and we return that. So now using these like kind of mini one statement programs, I can compose bigger programs. But what does this do? So like kind of the point with free is that we're separating the program itself, the program definition, and the behavior. So we have the free monad and interpreter pattern. So what we've done so far, we've defined this DSL. We've got say, receive, ask. And we've used free to compose a program out of these simple statements. But we haven't defined any behavior. So what we need to do now is create an interpreter. So this is an interpreter, and this is basically a function. So it's an object with an apply method. And it takes one of our commands. So it just takes like could be a say, or receive, or ask, and it runs it. So you can see here, so in receive, I do readline, and then with say, what I'm actually doing is I'm using a Scala sysprocess to just shell out and call the OSX say command, just like the bash script did. And yeah, so here I just have a function that processes each of my case classes or case objects that extend stand-up DSL. And this is completely separate to the program itself, right? So we define this program with a full comprehension, and we haven't defined the effects. It's completely separate. And this is bad code as well, right? This is like not functional. So here we've got like, when we do readline, we read a line for standard input, that blocks. When we do say, that's like very side effecty as well, and it blocks as well. It blocks until that finishes saying stuff. But at the same time, this is really small. You can kind of, this is like 10 lines almost. You can build arbitrarily complex programs with free. Like you can have an arbitrary complex program in your full comprehension, and you can just test your interpreter. So let's have a look. So here is the program using free that simulates our stand-up. So let's have a look at it. So first we say something. So we say, good morning, everyone. And then we ask how Jacek is. And if Jacek's good, we decide that we're going to respond with, great, glad to hear it. Otherwise, we say, oh dear. And then we say that. And then we ask some other questions. And then we get into talking about the tickets in the stand-up. And we have some way of like driving the conversation. And eventually we can terminate by just pressing E and saying end the stand-up. So this is a lot of code, but it's actually quite simple, right? So we're actually just using say, ask, and receive. And a few things here that are new that I haven't shown you before. So we've got this lift method here. This is, previously we had like free.liftf. This is now just used in the postfix position. Also this until thing, so having looping inside the monad. So let's have a brief look at that. So here we're inside our stand-up program, and we're saying until some terminating condition, run this mini program inside. So like this is the code to implement that. So we have a terminating condition. We have a little program that will generate a value t, and then we run that program, and we flat map it, and we say, okay, if the result of that program was our terminating condition, we're done, return that value. Otherwise, we're going to recurse and run it again. So Monad is actually powerful enough to give us looping constructs. So we can kind of create very powerful programs just using Monad. And this isn't like the most generic code. I just wanted to try and make it readable. Okay, so demo. So let's start with the language. So this is what we saw before. So you can see at the top, we've got our DSL that consists of these 3 commands. And we have this syntactic sugar that I've added. And then we have the stand-up. And this is our long program that hopefully makes sense. Yeah, and what we want to do is we want to run this program with an interpreter. So if we go to this OSX stand-up, here we have the interpreter that we saw earlier. And this is just an object that sends out. So we can run this. And what we're doing is we have the stand-up, which is our free monad of stand-up DSL that returns unit. And free monad provides this fold map method. And you can basically read this as run or interpret. So we're going to run this program with the OSX interaction interpreter. So let's give it a run.
How are you today, Jacek?
And I can like answer like, I'm good.
Great. Glad to hear it. Where is Russell this morning?
We don't know.
Any updates to production? Okay, moving on. Shall we talk about this ticket?
So now if I go back to stand-up, so now we've gone through this kind of beginning section, and now we're in this loop. So the possible options I've got are like, let's talk about the next ticket.
Okay, let's talk about this now.
Or we could be talking about it for too long, and our Scrum Master gets frustrated.
Okay, let's talk about this later.
Or he just doesn't know what's going on.
Sorry, I didn't quite catch that.
And then eventually we finish talking about all our tickets, and we can end.
Okay, great. Thanks, everyone.
So, like, I've shown you this thing, and it's kind of weird because why am I defining my program in a full comprehension versus just writing some normal code? And I mentioned separation of concerns. So the interesting thing here is that the interpreter is completely independent. So let's have a look at some other interpreters. So my interpreter was very side effecty, very non-functional. It blocked and read and write from the output. But we can test our program with a different interpreter. So our program is pure, it's just data. And let's have a look at how we can test it. So here is a test interpreter, and we create the interpreter, we give it like the input that the user would have given, and we're going to capture what the program said. So like this will be like, good morning everyone, and stuff like this. So what we can do with this, if I look at this test, is we can get our stand-up, use this test interpreter with like a canned set of input, and then we can run our stand-up with that interpreter, and we can check the values that it spitted out, and we can check the length of the results and stuff, and we can just print that. So I'll just run it. This is interesting because our program, when we test it, we don't have to check that it did the right side effects. We can just simulate what would have happened, and we can just drive the program with a test interpreter. That's pretty cool. If you were here a few months ago, you know that I like Scala.js. So here is a Scala.js interpreter for this. So nothing about the stand-up or free Monad. These are kind of cross-platform. So here we have a browser interpreter. And here, when we evaluate the commands, we do like a JavaScript alert or a JavaScript prompt to output it to the user. So let me just run this one in the browser. Let me zoom in a bit. So yeah, we're now in the stand-up again. I can say, good morning everyone. How you say Jacek? He's good. Awesome. Where's Russell? Any objects in production? Moving on. And now we can, we're in that loop, we can do the same thing. And I'll just end. So. Let's go back to the presentation. So that's my demo. Why is this cool? We could have more interpreters, like we can kind of, they're independent, so we can add more interpreters without having to like test our program again. But we can also add more programs without having to test our interpreters again. So we could like add an interpreter for doing a Slack bot, chat bot, and that would have, the logic would all be tested for our stand-up. Also, like the DSL we wrote, it wasn't really specific to stand-ups at all, right? It was just kind of say, ask, receive. So we could like write a proper chatbot that was actually intelligent and not just me driving what to say next. And we could reuse the interpreters for that as long as they're tested. And also it's cool because there's a bunch of cool things in the Scala community that like use this. So Doobie is a principled functional library for interacting with JDBC, so for doing database stuff, and that's using free monads under the hood. And the F monad is a really interesting one. So who here has heard of monad transformers? Quite a few people. This is nicer. Check it out, because monad transformers are horrible. If you haven't heard of monad transformers, stay that way.